Okay, let's go on to, this is chemistry or Chem25DBlake. And we're continuing on with Lewis structure examples, the one we just finished. We're in week 2.5, by the way. It's Thursday, week 2.5 by the time you get started on this one, the earliest. We just did 43 out of that list. 44 is next. It's sulfur dioxide. Okay, how do you do that? Well, first you got to list every atom that's there. A sulfur and an oxygen and an oxygen. Then you need to put the electron dots in from here. Sulfur's over here, has 6. Oxygen's over here, has 6. Oxygen's right above sulfur. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Total is 18 electrons. Now this is sulfur dioxide, which is a gas. There is a sulfite ion. No, never mind. I was thinking about something else. Okay, so we want our answer to be 18. So we need a central atom. Even though oxygen technically is a little closer to carbon, we're going to use sulfur because it's the odd guy out. S-O-O. Let's put it in the middle. Then, next step, put it in the shared pairs. Then, next step, give everybody 8. Well, give everybody 8 unless, give everybody 8 if they're here, 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 or here, and for sure if they're in the second period. Maybe not if they're in the third or below. Make them end up with 6 if they're here. Make them end up with 4 if they're here. Make them end up with 2 if they're here. Okay, so these all get 8. Or they all end up with 8. Now we add them up. There's 8, 16, 18, 20. That's 2 too many, which means we have to delete a pair and move a pair. Oh, this time I'm feeling lucky. Let's delete a pair on the top, and then we'll move this pair in here. Okay, when we do that, we have oxygen, sulfur, 2 pairs in there and 4 in there now. Oxygen look like this. Let's replace them with sticks. The shared ones with sticks. You cannot do this by watching me. You have to take your paper and your pencil and you have to do it on paper. If you do it, it's no problem. Well, it might be a problem, but it's impossible to not work it. If you don't work it, it's impossible. Okay, so let's do valence shell. This is the Lewis structure right here. So you're done here. However, let's go another step and spread this electron pair, which has an angle of 90 there and 90 there. Spread those out so it takes up some of this 180. And do the same over here. You don't want 90, 90 when you got a 180 here. Okay, now it turns out this is going to have a resonance structure. So there's going to be a double arrow to another one that's opposite of this, where the double bond's over here and the single bond's there. So, whoa, I have a mistake. Right here. And too many carbon on there. Or too many electrons in there. Come on. There you go, like so. Now the other one, if you do it the other way, would have the double bond here and pair, pair. On this side, single bond, pair, pair, pair. So it'll just be the mirror image of this. Okay, so I want clear annotations, and on the next page we should see that. Here we go. Here's both of these forms. So this one does resonance. It's got the double bond character in both locations. And it's got a character somewhere between 2 pairs and 3 pairs in both locations. Okay, the next one is ozone. Ozone is O3. Okay, so it's got an oxygen and an oxygen and an oxygen, each one with 6 valence electrons, so electron dot has 6 dots. And you add that up, and that's 18. 3 times 6 is 18. So you're going to need a central atom, and your only choice is oxygen. So one of these oxygen will be in the center. There will be an oxygen on either side, let's say. Then you put in a shared pair. Then you give everybody 8. Then you add them all up. There's 8, 10, 12, 14, 16, 18, 20 again. This is going to look a lot like the last one, except you're going to have a central oxygen instead of a central sulfur. Now that makes sense, because sulfur's right below oxygen. So if sulfur's a central atom and oxygen's a central atom in the other one, you should end up with everything being the same. You just have an O here and an O there instead. They're in the same family. If your things are in the same family, your central atoms are going to act the same. Okay, so we have to delete a pair and move a pair. This time, let's take this pair out and move this pair down in there. We'll end up with the same 2 answers. Just getting there a different way. So if we did that, we have oxygen. Oxygen, let's see, I kept that one. Here I got pair, double pair. Oh, like so, like this. Now put sticks in for the share pair. I have 1 stick there, 2 sticks there. Keep that pair. Okay, and this is your Lewis structure right here. The thing is, though, this is going to have resonance. It could just as easily go the other way. Good question is, well, how do you know if it has resonance and how do you know if it doesn't? Well, let's get this far and then we'll worry about it, but that is a good question. We're not going to answer that today. So let's use valence shell electron pair repulsion to push things around, and these will take up some more space over here, and this will push those down, so you'll have O, O, something like this. And then it's mirror image. So I'm going to delete my annotations here. And that's what we should have on this page. I have, though, a problem here. I don't have my electron pair here and there. Now, what I should do. Okay. The next one, sulfite ion, SO3 2-. Okay, so I have a sulfur and an oxygen and an oxygen and an oxygen, SO3. Now I've got a 2-, I got a charge, so I got to change the charge over here. They're both in the has 6 family. Both in the oxygen family. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 4 times 6 is 24 electrons. And I have 2 extra ones. Plus 2 electrons gives me 26 negative electrons total. So I need a central atom. Let's make it sulfur because it's the odd guy out. Give everybody shared pair. 1, 2, 3. Shared pairs. Then give everybody 8. And sulfur, don't forget. Now I have 8, 16, 24, 26 electrons when we add this up. So this one's going to be done. We have a sulfur bonded to 3 oxygen, and this has 8, and this has 8, and this has and that has a lone pair. And so this is your Lewis structure right here. And I think I have it drawn on the next page like, well, I'll show you how I did it. Clear annotations. You can also draw it. Ooh, oh, I messed up. What did I do? Okay, let's go from here. I forgot that I had an ion. Okay, so what you have, there's no double bond in there anyway, so we don't have to worry about that. I'm going to rotate it around and put the lone pair on the top just because it's not right or wrong, it's just normally what we do. This is actually tetrahedral. So I don't know, I didn't look all that close. I might have it drawn this way. And this means you have an ion. So you got to bracket in your polyatomic ion. And those extra 2 charges are one of these. You don't know where they went. They're just there somewhere. So this molecule kind of looks like this, rather than these being, there's 3 of them down and 1 up. Remind me when you're in and I'll show you that. Okay. Let's go to the next one, which, okay, number 37 does not follow the octet rule. Members of the boron group do a hybridization, so edit, copy, edit, paste, come back here, clear annotations. Okay, members of the boron group do a hybridization to end up with 6 valence electrons instead of 8. Now you're going to find out later that anything in this family does an sp3 hybridization, but that doesn't change the octet rule for them. But for boron, they end up at 6. They do a hybridization. We'll talk about what that means more later. But they end up with 6. Okay, so we have BH3. So I have a boron and a hydrogen and a hydrogen and a hydrogen. Boron is in the 3 family, same as aluminum. Has 1, 2, 3. There it is right there. One, two, three. Hydrogen, hydrogen, hydrogen. Pick a central atom. Let's pick boron. First of all, it's closer to carbon. Put an H, put an H, put an H. Need shared pairs. Here, here, here. Give everybody 8, except hydrogen doesn't give 8. Get 8. But, oh, no, we don't get 8. We get 6 this time. I was thinking about something else. This one doesn't follow the octet rule. So we're done. So it's just B, H, H, H. Done. Okay, I have a feeling my timer's not working, so I gotta check the time here. Nope, we're good. All right, so let's go to one more then. This is an expanded Lewis structure. Okay, I don't remember doing that one in the other class. ClF3. Okay, so edit, copy, edit, paste. Go back here, clear the annotations. Okay, we have to about tell you when it's an expanded octet. I'll probably tell. Okay, I won't give you an expanded octet on the test because they're not something you're going to run into often enough to worry about. But it is important to be able to do them. What was that? PF3? No. Which one was this one? That wouldn't be expanded octet anyway. ClF3. There we go. By the way, when you put that fluorine in with compounds, weird things can happen. See, normally chlorine would be your more electronegative element, and it'd be trying to take electrons. But you're putting it in with fluorine, which is even more electronegative than it is. So weird things are going to happen with this one. Okay, so you have chlorine. So I said in one of the videos that your halogens are not normally central atom, but we're putting this halogen with something more electronegative, so it can be. So chlorine gets how many? 7, and so does fluorine. They're both halogens. It has 7. It has 7. And 7 dots. 1, 2. Oh, come on. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Well, 4 times 7 is 28 electrons. Okay, so we're going to put chlorine as the central atom, and a fluorine, and a fluorine, and a fluorine. Give everybody a shared pair. Da, 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 da. Give everybody a 2, 4, 6, 8. 2, 4, 6, 8. Cl, not C. Okay, so now I have 8, 16, 24, 26, which is not enough, but I'm telling you there's going to be an expanded octet, and where those extra ones are going to go is on our central atom chlorine. So we have an F, an F, an F, and an electron pair that's here, and another electron pair. Now we have 28. First, we do when I recount this. I'm not all the way done. Okay, so I have 2, 4, 6, 8, 2, 4, 6, 8, 16, 2, 4, 6, 8 is 24, 26, 28. And that one's done. Okay, we'll go to another video for the next one.